Hi, this is Mahesh Kosuri. Yeah, here we are going to discuss of SAP BW. SAP BW or data warehouse. Sorry, writing is very poor. Okay, in the last session, actually we have discussed of some concepts like why the customer needs data warehouse system, right? We have taken some example like sales, purchases, and returns and employee salaries like that we have taken. Now let us understand the data warehouse structure. Generally, if you take Oracle, if you take Oracle software, why it is okay. If you take Oracle software, they have their own database system, right? So that's why with their database they can build their own data warehouse. They can build their own data warehouse system, right? In the same way, MySQL or Microsoft SQL, whatever you take, any database software products. On top of it, you can build your own data warehouse system, right? Here is also you can build your own, I mean, their own data warehouse system. Your own in the sense, their own data warehouse system they can build. But when SAP started, SAP is not having any database by that time. So that's why they use it to use the either the SQL. Sorry. Oh, I'm new to this pen. Sorry. So here is Oracle, MS SQL, and let us take those two are the popular products, right? So I'm taking the SAP here, and this is SQL data warehouse system. Of course, my MS SQL also they have their own data warehouse system. Oracle also they have their own data warehouse system. So, but backend is the DB, right? So for SAP, when they started their applications, they do not have any their own database. So that's why either they use it to go with MS SQL or Oracle. It depends on the customer. If the customer prefers Oracle, then they can install their SAP software on top of the Oracle system. Or if the customer go with SQL, I mean MS SQL or MySQL or any other databases, SAP application they simply install on top of it. So that what happens, your SAP ERP, whatever you create in this SAP system, those objects are stored in these databases. So whatever the objects stored in this database, generally we call them as metadata objects. Metadata objects we call. But I guess around 8 years back or almost, yeah, around 8 years back, I guess, if my memory is correct, the SAP have come up with their own database that is called HANA. So from that onwards, SAP applications working on HANA database also. As I said previously, any data warehouse system generally we classify in the two parts, right? That's what we discussed previously. One is one is OLTP system, OLTP system. Another one is OLAP system. This OLAP is the data warehouse or business warehouse in SAP terminology. We call it as the BW. But OLTP system, SAP OLTP system, we call ERP. ERP systems. Here we call ECC, SAP ECC, Enterprise Central Component. ECC means Enterprise Central Component. Okay, so SAP, I mean, as I said, like any ERP system, we classify as one is application software, another one is the data warehouse software. Application software is the OLTP system because here, as I said, like in my last video, here we use all the transactions, everyday transactions. We use this system. OLAP system at the end of the day or at the end of the 1 hour, frequently we take this data from the OLTP and we load into the OLAP. Mostly the customers they prefer to load their transaction data at the end of the day, so that in the quiet hours we move our data to the OLAP system. Quiet hours in the sense when the users logged out of the system, then whatever the data is available in the OLTP, that data we will push to OLAP system. So that here our data will be stored. All the historical data will be stored in the OLAP system. As I said, like here you see OLTP system here, right? Now ECC. So SAP SAP OLTP system, we are calling it as ECC, but this ECC system works on the different databases. Like as I said, like SQL and Oracle, nowadays HANA, right? So when the SAP starts to work on the HANA systems, then they renamed their products. They renamed their products as ECC. They renamed as S4 HANA system. S for HANA. This OLTP system. OLTP system they renamed as S4 HANA system. This OLAP system they renamed as BW for HANA, because your BW system now lying on the HANA database, whereas OLTP system, that is ECC system, lying on the S4 HANA HANA database. That's why your ECC renamed in the sense it is the latest software. It is not only the renaming, it is the application entirely rebuilt with the new features. So they started to call as S4 HANA. This BW for HANA also, it is not only renaming, the entire software has been rebuilt with lot of enhancements. So they started to call us BW for HANA because this BW for HANA, it works only on the HANA database. The same way S4 HANA, it works on the HANA database. Of course, whatever the old products is in the sense like either ECC or SAP BW system. They both work on the all the databases like either the MS SQL or MySQL or Oracle. So all these kind of databases it will work. Okay, this is the major difference of renaming or rebuilding the products with the new names. So here we learn some of the concepts of the BW for HANA. BW for HANA. Okay. So here, what we discussed here, OLTP system, right? OLTP system. This is online transaction processing system. Everyday transactions we will collect here. Whatever the sales, whatever the purchases, whatever the payments, and whatever whoever sorry, employee salaries, everything we need to maintain in our, generally we maintain in the OLTP system. So if you look at S4 HANA system or ECC, generally SAP has classified their ERP systems based on the applications, based on the business applications. What is the business application here? Your sales is one business application, right? Sales is one business application. Purchases are one more application. And finance. If very big organizations, they maintain the finance as one core department. So finance is one department or one application. And production, if it is the manufacturing plant, then production is one more application. Plant maintenance is one more application, right? So these many applications or these many departments generally works together to run the business, right? So for the sales, one application they maintain. If you go to any retail market, any large chain retail market, they use the desktops to enter their sales information here, right? They enter the customer data and what are the products they bought and what price, what is the discount, what date they bought. So entire data they will collect from the sales application, right? The same way the purchases, who is the supplier? For purchases also again we maintain one application. Who is the supplier? What kind of products we have purchased from them? What date they purchase? What date we purchase? What is the invoice details? Whether the invoice paid or unpaid or is still pending or overpaid. So all those details we maintain in this purchase department. Finance department, what we do here, the finance will release the payments either to the salespersons or purchases what we purchased. Those payments will be released from the finance department, like whether the employee salary or plant maintenance expenses or production expenses, whatever the expenses are there. So we with this finance department will take care of releasing the payments or receiving the payments. The same way production department. So these are all the core components, right, of any business. If you look at, if you take any kind of scenario, any kind of business, so these are the core components. Other than production, production means like if they have the plant, if they are the manufacturing plant, then fine. They need the production planning application, or else that does not need. But these three are the core, right? Purchases, finance, and sales. Other than these three, nothing will happen. No business at all, right? You need to purchase something, you need to sell something. Other than service industry, even the service industry also they do some purchases, right? So this is what happens. It all depends on the customer business scenario. If it is as I said, like if they are the manufacturers, then they need the production application. If they are only the retailer chains, then only just they need these three applications. Of course they may need some other applications also, but these three are the core components. So here they maintain everyday transactions, right? So now here all these components together we are calling, in production planning, let me rename it as the logistics. I call it as logistics. That is the better name. Logistics. So all these components together, we are calling it as the S4 HANA. The core components they included in this S4 HANA application. So that is the reason we are calling it as S4 HANA. So you have different applications here, right? Sales you have, purchases you have, finance you have, logistics you have. For all the core components are here, right? So now you need to collect this data to your data warehouse system. That's what the BW4 HANA comes into the picture. Here we design our system, our data warehouse system. Here we will design. Say, suppose you are bringing the sales data here. So we maintain one sales related folder, sales folder. Let us assume sales folder. Generally, in the BW system, we call it as application component. Application component. We call it as application component. So sales and distribution. Suppose sales, sales and distribution. We take the data. So all the data we maintain in the sales distribution application component. Again, this application component, again you can divide as per your requirement, because your SD will have number of tables, number of features, right? All the features or whatever the required features, required data you want to bring into the BW, so you need to maintain subfolder so that you can navigate easily here. Here, from here, what data we will collect? That is the important question actually. What data we will collect from the sales application? That is one important question. So data we are talking of it now, right? From the sales application, we are talking of the data now. What type of data we need to collect? It means suppose if you go to the sales, if you look at the sales information, let me take it to the another page. Okay, here I will talk. Let us talk here. Okay, what data here we maintain? If you take the sales application, mostly what data you maintain here, you collect the customer information, right? His phone number you will collect, his email ID you will collect, and this customer, what date he purchases, and what items he will purchase, and what rate he will purchase, and any discounts you are offering, any purchases, and total quantity you will maintain, right? And a discount amount you will maintain, tax amount you will maintain, and payment mode also you will maintain, right? So this much of information generally you will collect in the sales. See, I'm taking very minute scenario. Okay, actually the sales will be the big one, right? Just I'm taking the end point. I mean, a end customer, what generally they do at the store, and how we store this data into the data warehouse system. That's what here we are going to discuss. So here, this much of information generally we will collect. If you look at this one, this customer phone number, email, date, these are all standard, right? This customer again may come in some other date, but this customer phone and email is the same. So generally, if you go to the retail store, generally we see one scenario like, hey, what is your phone number? They enter the phone number and they retrieve the customer information. Or if they enter the email, they can retrieve the customer information, right? So like that, they maintain the data. Once they retrieve the customer information, then they can retrieve the customer transactions also, right? So here What I'm going to do, I'm going to split this record, entire record, into two parts. Here I maintain the customer table. Customer table here I maintain. And here I maintain the transactions. His transactions. This is the customer table. Here I maintain the transactions. Customer table here is in the sense like what is the information I will maintain? Customer number, customer phone number, customer email, customer name, right? Or you can maintain he belongs to which state, his zip code or pin code. That information also you can collect from him, right? So this is the data I maintained in this table. Now in this transaction data table, I maintain, I do not require all this information here. So what I can maintain, just I will take the customer ID here and I maintain his everyday transactions, right? So I maintain everyday transactions here. So here what I maintained, customer ID only I have maintained. So if we are aware of the SQL, just we maintain the ID here and ID here. So this is the primary key and this is the foreign key, so that we can maintain the relation between these two keys. So that if I retrieve this customer ID, so that I will get the customer information along with transaction data also. So transaction data. So now you can simply classify your data as this is the transaction data. This is customer master, we can call it as customer master. We call it as customer master. This is sales transactions of the customer. Sales transactions of the customer. That's why generally in SAP, when it comes to the ERP data especially, we classify the data as master data and transaction data. Why we are calling it as a master? Because these masters are mostly connected with the, sorry, this master data is mostly fixed for very long time, very long time. It may be changed, but the data is uh, constant for quite some time. Why? Because if you take the customer name always almost it is a fixed one, right? Unless otherwise he go for the change of his name, the name is fixed. His mobile number may be changed, his email may be changed, or his other properties may be changed, but his name is constant, we can say. At least up to certain time. Every day he won't change the name, right? So that's why this master data, this data that is constant or fixed for quite some time, that's why we call it as the master data. And here we maintain the primary key also. This key now is connected with the transaction data table as the foreign key. So that whenever you call the customer ID, you can call the data from this table and from the other table also. Other table here, transaction data. So this is the scenario generally we see in any data warehouse system, right? Here, what information we will have, customer is have, customer data we will have, and item or material data also we will have here. Do we maintain all the material information here? No, not like that, right? Just if we maintain the material ID or item ID, that's enough. Say we are buying some material. This guy is buying, some one customer is buying some material from the shop. So what happens here generally, here I maintain one table. This is the material table or item table. Material table or item table here I maintain. Now I give one ID here. ID I will give. I will maintain the material name. Material name. Say suppose steel. Okay, steel. Material name is steel, and the steel is having some properties like its width, its height, steel structures. I am talking about whether it is the rod, circular rod, or whether it is the C channel, or it is hollow tube. If it is hollow tube, what is its radius? What is its density? What is its strength? So all are the additional information, right? So here I maintain only the ID, material ID I will maintain here. So that what happens, okay, this customer done some transactions, what he purchased, then I will retrieve, okay, he purchased the steel. Okay, what is this steel properties? What are the steel properties here? So you maintain all the steel properties in this table, right? So what happens, I can retrieve even the material information also, right? So here material has been joined with this table. Here customer joined in this transaction table. Now material also joined with the transaction table, right? So two tables already we have connected here. So if you extend this same kind of scenario for the other tables, this transaction table is surrounded by or joined by different tables. Here is one table. Here only material I have maintained. Customer material. Mostly that with this transaction you will see only if he is the manufacturer. If he manufacturing some steel components, this kind of definitely here it is plant also we will join here, right? Why? Because here the plant is connected with this, so that if this material is connected with the plant, because this material where it is getting manufactured, which location it is getting manufactured. So the plant information also I will join with the material, right? So like this transaction table generally joined with n number of tables. This is how we design our ERP systems, data warehouse system in general. So this one is simply we call it as this kind of design. We call it as star schema. Star schema we call, because one table is surrounded by one table surrounded by n number of master data tables. So this one we call it as either fact table or transaction table, and all whatever the objects, whatever the tables surrounded here, these are all master tables we call. So it looks like star, that's why we call it as the star schema. But system SAP data warehouse system is something different. What they have done, We discussed it, right? Star schema we discussed, right? So now, so star schema we discussed. But SAP, what they did here, you maintain the customer. Here you maintain the customer table. This is okay. In this customer table, customer name we maintain, customer ID we maintain. This customer, he may belongs to what region he belongs, which continent he belongs to, what country he belongs to, which region he belongs to. So different kinds of analysis we can do based on the customer ID and based on the different parameters. And also this customer, as I said, like he will have some phone number, email, his race, his date of birth, what else? So here these are all additional properties of this customer. Customer ID, customer name is fine, but these are all additional properties also we will collect, right? Sometimes you may need to collect these are all the things from the customer. Even he whenever he come to the shop, sometimes we will collect this information because of analysis. Because suppose Indians, they prefer to buy some kind of food, or if you take the Chinese, they prefer to buy some kind of food, or if you come to the India only, South Indians, the Tamilians, they try to they buy some kind of food items, and Andhra people they buy some kind of food items. The same way North Indians are different, different kinds of people, different kinds of foods they buy. So to analyze the data based on the customer interest, we maintain some of the additional properties of the customer. Not only that, even even we want to see the customer data in the aggregate. I mean, we want to see the customer sales information in the aggregated mode based on the region, based on the race, based on the continent, based on the country, based on the sub regions. So for that also we maintain one more table here. That is generally hierarchy we maintain. Customer, I want to display like, okay, who is customer here? Okay, this is the Asian continent. In the Asian continent, I will maintain China, Singapore, and India. Okay, in India, how many customers are there? Customers. Again, I will maintain in India, South and North part of India, south part of India. Again, in the south, I can maintain Chennai city and Hyderabad city. In north, I can maintain Mumbai, I can maintain Calcutta. So under Calcutta, how many customers are there? Under Mumbai, how many customers are there? So like that also, I can do the classification or analysis, right? That's why I maintain one more table here, and that is connected with the customer. And this customer, see, we see in any application, I mean, even general application also, we see like, hey, what is your first name? What is your last name? What is your full name? Like that way they ask, right? So what SAP has done for this customer, not only for the customer, for any master data ID or its name, you can maintain different type of test. They provided long test, short test, and medium test. So three type of tests you can maintain for. Oh, what happened? Come on. Okay. So here you can maintain for each customer you can maintain different type of test. Like short test you can maintain, long test you can maintain, and medium test also you can maintain. Whatever the properties here we are maintaining, right? His age, region, phone, email, whatever you maintain. So these are all this is all information required to analyze the customer behavior. Here you maintain the customer ID, and maximum you maintain customer name. Customer ID only let us take, okay? This is the ID. This ID, customer name is also not here. Customer name is also we maintain here, or here itself we can maintain. This is the only ID I maintain here. So this ID is now available in the hierarchy table. This ID is available here, and this ID is available in the test table also. So what is happening in this object? This object, what is happening here? This object we use to analyze the customer behavior. Customer behavior in the sense, suppose now we said like the transactions we are maintaining here, right? Everyday transactions. Say suppose every day he is coming and buying different type of products in our shop. Okay. So what day he is buying what type of products. Once we analyze, so that we can understand that okay, this guy buys Wednesday one type of particular item he's buying, and Monday he's buying some item, or some festivals he buying some kind of items, so that we can understand the customer behavior, right? And in age group, suppose if we maintain okay 25 years age customers what kind of items they are buying, or 30 to 35 age group what kind of items they are buying. So this all the analysis we can do if we can able to collect the customer information and store in these tables, right? That is the reason SAP what has done, they segregated the entire data of the customer into three tables. They maintain the hierarchy table, they maintain the test table, and they maintain the attributes table. This is called attributes table. Attributes table means properties of the customer, additional properties of the customer. Additional in the sense other than customer ID, rest of all are for us additional properties, right? So all this together we call it as one master data object. This one we call it as master data object. And this table already we know. This is the transaction data table. This is transaction data table. We know this, right? So now once you connect this customer ID with transaction table, here also we maintain the customer ID, right? So this customer ID we connect to the transaction data table. Then We can analyze the transactions of the each customer and customer behavior also we can analyze. This transaction table not only joined with the customer. As I said in the previous screen, this transaction table connected with the material table also, right? Again, for the material also we maintain the same kind of structure, like the material extra parameter, extra properties, hierarchy, and a test table we maintain, right? So this is one more master data object. Material material master data object this is. See now this transaction table, or we call it as the fact table. Transaction table, or we call it as the fact table. This fact table now surrounded by master data objects. Earlier we have seen only the star schema, just one fact table that is surrounded by one table. Now this transaction data table or fact table connected with one table. Again this table extended with other tables. That's why this kind of structure we call it as snowflake schema or extended star schema. Extended star schema we call snowflake schema, or extended star schema we call, because this is the extension of the star schema, right? That's why we are calling it as extended star schema. Okay, now let us come to the BW terminology. In BW terminology, this master data object is simply we call it as uh, info object. Info object. This master data object, we call it as the info object. And this transaction data table, we call it as info provider. Info provider, or simply in general terminology we call it as info cube also. Not only the info provider, we call it as info cube. Info provider means something different. Okay, let us stick to the info cube. This is called a transaction data table or fact table. We call it as info cube in SAP BW system. And master data object, we call it as the info object. Again, this info object, you can divide it as characteristic info object and key figure info object. Key figure info object. This is the characteristic info object, in fact. This entire master data object is characteristic info object. See, these tables are optional for us. This attributes table and hierarchy table and test table. These are all the optionals. Whether you need the customer information, extra information, if you really need, then you can extend your master data object to by creating the attributes table or test table or hierarchy table. Of course, in SAP, test table by default available, but attributes and hierarchy options, these two are the optional tables. If you really need, you create, or else leave it and just maintain the customer information. ID only you can maintain. So this entire object, we call it as the characteristic info object. This is in SAP. This is characteristic info object. Okay. Okay. Here we discussed of characteristic info object, right? Master data object is nothing but characteristic info object. And we talked about the key figure info object also, right? So if you take your transaction data system, if you take your transaction data table as we discuss, oh, sorry, here you maintain your, here you maintain customer ID and material ID here you maintain, and now you maintain item price, right? Price you maintain, and its discount you will maintain, and final price you maintain, right? So this information also you need to store in this table, right? So unit rate you need to maintain, discount you need to maintain, final price also you need to maintain. So these columns also we need to create now. Customer ID already we have created, right? In the previous board I have shown you. We need the customer ID and material ID. Now we need these fields also. These field names are nothing but here objects, key figure objects. So because these are all either whether they are in the numerical values or numerical value with unit. Mostly in ERP systems, what kind of things we see? Only the all the physical quantities we see, right? Whether the price or unit or quantity, those kind of units generally we see. So to store that information, to define the column names, we need the objects. We call them objects in the SAP. So here we need we need three more objects. Those objects are nothing but key figure objects. We call them as key figure objects. Key figure objects. And the previous one is characteristic info objects. The previous one is characteristic info objects. This is master data object. That's what we discussed, right? Here, key figure objects. This is to store, measure information. We call it as measure information. These are the measures actually. Not only the measures, we call them key figure. And why we are calling it as the key figure? That is another important thing here. Key figure is nothing but here. Say suppose here is the customer, right? Here is the material ID. We have customer ID and material ID. Say suppose you have one customer CU001 and material 001 you are maintaining. For this combination you are maintaining some price like 100 you are maintaining. And same customer suppose CU001, now he is buying another item material 002, 2000 you are giving. So for me this is the key. This is one key and this is the another key. So this key is having some numeric figure. That's why we are calling it as the key figure value. This is key figure value, this is the key figure name. This is key figure name and this is the key figure value. This is the key actually, right? So that's why they named it as key figure object. Object is nothing but column name here. Okay. So key figure object, this key figure object we use to store the numeric values with their units. If it is the currency, we maintain currency unit. If it is quantity, we maintain the number. If it is some weight, we maintain its corresponding units, whether kgs or pounds. Like that, we maintain, right? So, in SAP terminology, to maintain, to store the master data, we design characteristic info objects, and to store the numeric values or transactions, we create key figure objects. What is this table? This is a combination of characteristics and key figures, right? Here, this is the characteristic. This is the characteristic. This is one more characteristic. This is key figure, sales rate, unit rate, key figure. This is discount. This is another key figure. This is final price. This is another key figure. So this entire table is combination of characteristic and key figure, right? This table is combination of characteristic and key figure. So once you group together these two objects, once you group together, you call it as info cube. This info cube is nothing but transaction table, right? This info cube is nothing but transaction table. How do we get the transaction table or fact table? Fact table is nothing but combination of the characteristics and key figures. So once you create the characteristic and key figures, then you can create info cube. Info cube is nothing but combining the required characteristics and key figures into one folder. Once you create the info queue, the system will create the corresponding transaction data table in the backend. So this is what first we are going to work in the practice session. What we are going to do in the coming session, we are going to create a characteristic object and one key figure objects we create, and we create info cubes. Okay. If you have any questions, please post your comments in this video, below this video. Okay. If I have time, I will come back to you. Thank you. Thank you for watching.